So hello guys, today we are going to talk about a very famous theorem which is Euclid's theorem. And the theorem is, there are infinitely many prime numbers. So we are going to use a method which is called reduction ad absurdum to prove this theorem. And what is this method? It's basically used to prove that things are false by assuming that they are true and showing that it leads to contradiction. So what we'll really prove is that the statement, there are not infinitely many prime numbers, is false, meaning that this statement, there are infinitely many prime numbers, must be true. So, if we assume that prime numbers are finite, we can call P as the set of all prime numbers, and it would look something like this. Prime numbers till z, where z would represent the last prime number. Now, let's create a supernumber, and we'll call it supernumber. That will be the product of all prime numbers, and then we'll add 1. So, supernumber is 2 times, 3 times, 5 times, blah, 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 till times z plus 1. That's our number. So, some things should be obvious about supernumber, and they are, number 1, it's bigger than z because it's a product of all the numbers plus 1. So it's bigger than z. Secondly, it cannot be a prime number because the last prime number, according to our assumption, is z. Thirdly, it's not divisible by any other prime numbers because supernumber divided by any number in the set P will have a remainder of 1. So it would always have a remainder. And last, according to number 3, supernumber must be a prime number. So, according to number 2, supernumber is not prime. But according to 3, it must be prime because it's not divisible by any other prime numbers. And this is a contradiction. So it means that what we assumed must be false. And what we assumed, that there are not infinitely many prime numbers, and it's false. So, there are infinitely many prime numbers must be true. And that's it. It's simple.